Now there were a few more shape commands that we didn't cover in the last lesson. These are our morphing commands, and I'm going to look at some of these in this video. So let's create a new file. I'm going to create a generic template file. Let's name our part. Okay, so as the file name suggests, we're going to be looking at morphing, but more specifically what's called our flexing commands. And then in our morph panel, in the shape ribbon tab, the flexing commands are those here, these 5 commands: the cylindrical bend, toroidal bend, twist, taper and stretch. Okay, these are what we call our flexing morph tools. So we'll start off by creating a block. We're going to be operating on this block with our different flexing commands. So let's create the block, use the first method, select the first point at the origin, at the global origin, coordinate system 0, 0, 0. Second point we'll pick anywhere because we can dimension it here. We'll give it a length of 30, a width of 30, and a height of 4. Now remember, when you're typing in values into the input manager, it is best and it is good to get into the habit of pressing enter every time you put in a value, because this will lock it in. As you see here in our height, we've entered our number, and if we press enter, it locks it in. Let's confirm this command. Now let's save our file. And now, since we have 5 different commands up here, I'm going to copy my shape so I have 4 other copies of it. So we come into our copy command. In the shape ribbon tab, we're going to be using our copy along direction. Now we want to copy our shape, so we must ensure that our entity filter is set to shape. If we leave it set to all, we may run the risk of picking the wrong entity. For example, if it is on all and we hover our cursor over our shape, we may think that we're picking the shape, but in actual fact we're picking the face alone. Okay, and that's no good. We want to copy the shape. So redefine last. We can unpick the face, set our entity filter onto shape, pick the shape. We're going to copy along the X direction, that's fine, and we'll give it a distance of, let's say, 50 millimeters, and we're going to copy it several times, 4 times, so we have 5 instances of this block. Okay, and now we're also going to copy our global datums, because we will need these as reference planes when we are using our flexing commands. So let's left click back in the entity field. Okay, you'll see it highlight. Now we will set our entity filter onto datum planes, and we could pick our 3 datums one by one, but since our entity filter is set to datum plane and we know that the 3 datum planes that we want to pick are the only datum planes in this environment, we can do a window pick. Now we'll pick all 3 of them. If we change to wireframe view, we can see our top XY plane is copied as well. So let's confirm this operation. Okay, so let's take a look at our first command, the cylindrical bend. Okay, so this is used to bend a shape with a cylinder. We're morphing a shape to the contours of a cylinder. So our first field in the options panel, we're prompted to pick the shape. So let's start off with our first block. We then asked to pick a datum. The datum is where our cylinder will be placed. So in this case I want to place it on the top down datum. We can't see this right now, so let's change our view, our display to wireframe mode. Left click the top down datum. Let's return to the shaded mode and you'll see our cylinder preview. Okay, so this is the cylinder that our shape is bended around, and you can see the preview or the echo of our morph of this block. So in our options panel we have a few fields available to make modifications to our degree of bend. Okay, we can change the radius or the angle. Both will have the same effect, they're just different dimensioning methods. So the radius, we're changing the radius of this cylinder. Okay, so the larger the radius, the more shallow the bend will be, and vice versa. Okay, and as you see, as we're changing the radius here, you'll see that the angle is also changing. This is because they're linked. As I said, they're just different dimensioning methods. So if we change our method to the angle being the angle of our bend. Okay, so let's just leave it at a value of say 75. We also then have the option to rotate our cylinder about the z-axis in this case, but it is about the axis normal to the datum, in this case the z. Okay, you can see how our cylinder is rotating, and that is changing our morph. So let's leave it at 0, enter. Then I have the option to keep the original shape. Okay, so this will keep our original block as well as create our newly morphed block. We can flip the side of our cylinder, the effect of this being pretty obvious. Okay, and finally we have the option to minimize surface data. Okay, and what this does is when it creates our new surface, it is essentially minimizing the data and keeping the file size as small as possible. Okay, so we will want this checked most of the time to keep our file size smaller and allow our history to run more smoothly. So let's confirm this operation. Okay, and here we have our cylindrical bend on our original block. Okay, so you can see how we're creating some nice shapes here. Next up, we have the toroidal bend. Now this is very similar to our cylindrical bend, except we're not bending our shape around a cylinder, we are bending it around a toroid being a ring, a donut shape. Okay, and this can have the effect of bending our shape effectively around a sphere or an ellipsoid. So let's select our next block. Left click. We'll pick our top down datum again, the datum on which we want our toroid to be placed. We're switching between our display modes here. Okay, and there you can see our toroid, a very large donut. So again we have different fields in our options panel to define the size and shape of our toroid, which will affect our resultant bend or flex. So in this case we can change the tube radius, the tube being the inside radius. Okay, and this is going to make modifications to the degree of our bend in that direction. Likewise, the tube angle will specify the bend angle along the tube direction. Okay, so it's going to have the same effect, it's just a different defining method. Okay, and you can see here how this is going to soften or increase our bend in this particular direction. Okay. Next along we have our outer radius or the ring angle, and this is going to define our outer radius of our toroid. The ring angle doing the same thing, just a different defining method. Okay, and let's take a look at the effect here. Okay, so you can see it's bending it along the other direction. Okay, making an odd torus shape here. We've got a self-intersection. That doesn't matter. This is making our sphere. Likewise, we can make ellipsoids. Okay, so we have these same options, these same settings, fields, as we did in the cylindrical bend, and they're doing the same thing here. So let's confirm this operation, and that's our toroidal bend. Save our work. Okay, next up we have a twist command. Okay, and this is going to do exactly that. It will twist our shape. So we pick our shape. We can then pick our datum. Okay, so let's say pick this datum, our side datum. Okay, you can see the echo preview of a twist. Now the twist starts from our datum plane. If we want a twist through our entire shape, we should place a datum plane on this endpoint, at this end surface. Okay, but in this case, the datum is also defined as a plane of face here, and then we will get our twist, also known as a spiral bend, throughout our entire shape. So in our options panel we can change the range of our twist. We can change the twist angle, so that's how much of a twist we have within that range. Okay, we can also set the twist axis. Okay, the twist axis cannot be parallel to the datum that we have defined. Okay, now we have defined a plane here, a plane of face, that happens to align with our side YZ datums. Okay, so this means our twist axis is the X axis. Okay, it's by default it is the normal axis to the datum that we have defined, datum being YZ. So in this case we cannot use a Y or a Z axis as our twist axis because they're parallel to the datum. Okay, so I'm going to leave this as it is now, and we have the same options: keep original, minimize surface data. So let's confirm this operation. And there we have our spiral bend, our twist command. Next up we have the taper. Now the taper is very similar to our draft command. Okay, it's just a different way to define the taper or the draft. So we select our shape, we pick our datum. I'm going to pick the end plane of face again. Okay, you can see how we are getting a draft or a taper to the shape. Okay, a taper factor greater than 1 will be an expanding taper. Less than 1 will have a contracting taper. Okay, comes to a point. Okay, in the range, we can modify the range in which our taper takes place. Okay, and in the same way as with our twist, we can set a taper axis. Again, this cannot be parallel to the datum we have picked, and we have the same keep original and minimize surface data options. So let's confirm this, and you can see how it is very similar to our draft command up here. Okay, finally we have our stretch command, our stretch flex method. Okay, so if we pick our shape, then we pick our datum, I'm going to pick the top datum. Okay, and here's our preview. Now stretch is going to stretch our shape in the X, Y, and Z direction in a specified range. Okay, now whereas a scale will scale our shape in the X, Y, Z direction, it is not within a specified range. Okay, so currently this does look an awful lot like a scale command, okay, this being our scale factor here. However, our scaling is taking place within a range, and we set the range here. Okay, now it's not so easy to see the stretch occurring on this cubic shape, so let me set our framework and change our framework from a box to an ellipsoid. Okay, our range is now an ellipsoid, and you can see how the stretch is taking place with an ellipsoid range. Okay, now I'm going to erase this block so we can see the stretch a little easier. I'm going to create a different shape. Let me insert a sketch. This top down datum, make sure use centroid defined by plane is checked by default. Every time we start up the software it will be unchecked. Let me create a pentagon. I will extrude the sketch symmetrically 2 millimeters, so that's 4 millimeters total. And then let's perform the stretch on our pentagon, our extruded pentagon. Datum, top datum. Okay, and you can see how our stretch is different to a scale. In fact, what I will do is copy this extruded pentagon. Let's just copy it once, a little distance. Okay, we'll also copy our datums. And let's perform a scale on this pentagon. Select the shape. I'm going to select the center as the center of this datum system. Okay, so this is the point around which our scale will take place. And you can see our scale. If we do it non-uniformly, we are able to scale in our X and Y and Z directions separately. So let's set them all to 1.5. Enter. And you can see our scale taking place. Now let's stretch this pentagon. Now our scale is still set to 1.5, but we have a range and we have a framework. We have a range for the framework. And you can see how our stretch is different to our scale, even though we have the same scaling factor. Now we're getting a different shape to our normal scale because the points on our shape are not being scaled by the same factor, they've been scaled within our range. Okay, if we select the uniform stress, we'll be getting our scale, our uniform scale, where every point will be scaling by the same factor. Okay, so this is only in the box framework. Okay, so this creates a uniform scale. This range is defining which parts of our shape we want to stretch. Okay, so if we enclose it all, we're stretching every point. See here, if we do not enclose it all, we're stretching only what is enclosed within our range. Okay, so that is how our stretch command works. So these are some of our morphing commands. These are our flexing morphing commands. And you can see they have quite a nice effect on our shapes. We can do a lot with them. We still have some more morphing commands available, and again these ones are also very nice. However, they're slightly more complicated, and we'll move on to them further along in this course.